guys, today we are going to talk about the third lecture of electrophilic substitution reactions. So here we talk about the nitration reaction. So here the reagent is used. Basically, you have to get the information about the reagent in the reaction. So here it is used the nitric acid and a concentrate sulfuric acid in the catalytic amount. So we can say like the 3 or 4 drops just required for a reaction, and the condition is reflex 55 degrees centigrade. So if you calculate it in a Kelvin, then that's become a 12 and 3 328 Kelvin. The temperature become 328 Kelvin. So generally the equation becomes benzene ring reacts with the attacked by the HNO3 and the nitrobenzene is formed, and as a neutralization reaction it is so H2O is also formed. And the next what we see here is the reaction. Before understanding the reactions, you need to understand how the reaction is proceed. So the first and the most important thing, the H2SO4 reacts with HNO3. So here the H2SO4 work as a acid and the HNO3 work as a base. Both of them are acid over here, but you have to understand like the H2SO4 is more acidic and HNO3 is less acidic at this place, so it works as a acid and it works as a base. When they reacts with each other, then this is formed and acidic medium, and this is the most important and it is known as nitronium ion. This is nitronium ion, or we call this nitrile cation. It is generated in an acid base reaction. So before going through any kind of things, you have to understand how it is formed. So how it is formed, that you will understand from this reaction. Here it is one of H that comes from H2SO4. So H2SO4 releases one of H, like as it is, like suppose this is H2SO4 and it releases one of H plus and itself becomes H2SO4 having one of minus. So this is known as conjugate base of a acid. Okay, over here this H plus is taken by this HO of HNO2 and this is formed, and now this is like a water group, so it is released to balance the positive charge. This bond breaks in the side of oxygen and nitronium ion is left with H2O. Okay, to understand the further reaction, you will see over here like these cation is attacked by the ring, or like it will attack on a ring, and as it attack, the resonance is stabilized and then bond is breaked by the H2SO4, not H2SO4, I'm sorry. Over here it is break by the HSO4 minus, and these minus abstract this hydrogen and this is formed. Finally nitrobenzene is formed. So this is the rate of reaction: concentration of cation, concentration of substrate, and the reaction proceed. And here we further discuss about the sulfonation. In sulfonation, what gonna happen,